name is Isaac, and welcome to my robotics devlog series. What I've been doing for the past year is developing an autonomous drone, and I thought it'd be a good idea to share it, and share some of my progress, and continue to share my progress. So, I've been programming for a few years. I started off using MATLAB several years ago, and I've been slowly transitioning from MATLAB to C++ and Python. Now, the reason I'm using Python and C++ partially is because they're a lot easier to use when programming for ROS. I've been using Python quite a bit more because, for one, it's a lot easier to use and easier to learn, and it's also similar to MATLAB in a way. And I've been learning C++ partially because C++ is a little bit faster, and it would be great to utilize for a much faster runtime application. C++ is a bit of a nightmare if you've never used C++ before. I went from MATLAB, where I could use matrices fairly easy and just parse through matrices. Then I went to C++ and realized it's not that easy. So then I started also learning this simulation software called Gazebo. Now, Gazebo allows for an easy transition from software to hardware. Now, I can code something in Python and have it work and have my drone flying around. Then I can easily put that onto hardware and it should perform the same. I think it would be a good idea to show you kind of where I started and some of the very first success that I had working with ROS and Gazebo. So, as you can see here, I have 4 different autonomous drones, and all I tried to do here, get each of them to fly in a little mission. So as you can see there, that blue line is the z-axis, and at the origin, where the drones took off, was the XY plane. Cross-section of where the blue line and the z-axis and the x and y-axis obviously is 0, 0, 0. So what I wanted to do here was get 4 different drones to fly around in a circle and really just see if I can get them each to do similar but a little bit different things. So as you can see, the first drone takes off from its position, flies in a circle. Same thing with the second and third drone and the fourth drone. But at the end, I wanted them to land in separate areas. So this was really just a proof of concept and to see if the Python code that I had was working, and yeah. So this is great and all, but just because something works in software doesn't really mean it's going to work on hardware. And this didn't work on hardware. When I tested it out, or when I was going to test it out, I realized that the Gazebo simulation area was quite a bit bigger than my testing area. The testing area is something like 3 meters by 3 meters, and the height of it is something around 4 or 5 meters. So I had to do a lot of changes, and I had to move things around a little bit. In the video I want to show you here, this is what I've successfully gotten to work on hardware. This video does show some of the building blocks. I know it's nothing special, but it is the foundation of where I want to go from here. So I gave each drone a different altitude. They follow the same X and Y exactly, but they are flying at a different altitude. Now another thing you'll notice is that the drones are kind of choppy in their flight. They go from one point to the middle point, and they stop. They go from the middle point to the next point, and they stop. And you can see it's very choppy and definitely not ideal. So in the future, I want to make a trajectory generation lead to a faster path generation. And we'll also keep from weird jerky motion that the quad rotors are having. In the video, you'll notice that the bottom drone is having quite a bit of trouble staying in the air. This is likely due to some turbulence the top drone is producing, and the bottom drone just couldn't produce any thrust on its own because of all the turbulence. But each drone does fly very well on its own. In that video, though, you'll see the drones I'm using are pretty rudimentary drones. These drones were built using scrap parts I had in the lab, and they are not really a reflection of what I want to build in the future. I did this mainly because I wanted, again, a proof of concept, and to prove that I could get things working on hardware. And damn if I did. From here on out, what I want to do is I want to get a drone that's quite a bit more advanced. I want something that's a little bit bigger, can carry a bigger payload. I want something that has a camera on board so I can do object detection. I want a stronger onboard computer because the drones that you saw were using an Odroid, which is strong, but not strong enough. I also want a better flight controller, I want bigger motors, and I want a better quadcopter. Thank you everybody for watching my YouTube video. I hope you all enjoyed it. I'm going to be going a little more in depth later on. If you guys want to see more code or how to get things up and running, maybe I could do a little tutorial series on how to get Gazebo up and running. I can also do, several things. So thank you everyone, and I plan on producing one of these videos every few weeks whenever I have some success and whenever I move along and whenever I have something to show. So I'm planning on every 1 to 2 weeks I'll have a video out. If you liked what you saw, hit that subscribe button, help me out. I hope to see you soon.